Question: ds is a whole of x plus 1 times whole of x minus 2 smaller than 0. Condition 1. X cubed is greater than 0. Condition 2. X minus 2 is smaller than 0. Solution. Let us solve this ds question using the variable approach. The inclusive relationship between a question and the conditions. If the range of the question includes the range of the condition, then the condition becomes the answer because the range of the condition is sufficient within the range of the question. Square is important. Ignore the squares and even exponents. Square factors and even exponents factors are always positive, so multiplying or dividing a term by a non-zero square factor or a non-zero even exponent factor does not affect the direction of the inequality sign. We should ignore the square factor or even exponent factor, whether it is in the denominator or the numerator. The first property of inequality. Multiplying or dividing an inequality by a positive number does not change the direction of the inequality sign. Positive rule in inequality. That is, if a is greater than b, then a times x is greater than b times x, and a over x is greater than b over x, where x is greater than 0. The first fundamental concept in inequality. If a is greater than b, which is greater than c, then a is greater than b, and b is greater than c, and a is greater than c. Also, if a is greater than x and x is greater than b, then a is greater than x, which is greater than b. Let us follow the first step of the variable approach by modifying and rechecking the original condition and the question. We are required to verify whether the range whole of x plus 1 times whole of x minus 2 is smaller than 0 is true. Whole of x plus 1 times whole of x minus 2 is smaller than 0 means that the factors x plus 1 and x minus 2 do not have the same sign. Thus, whole of x plus 1 times whole of x minus 2 is smaller than 0 means that x plus 1 is smaller than 0 and x minus 2 is greater than 0, or x plus 1 is greater than 0 and x minus 2 is smaller than 0. That is, x is smaller than negative 1 and x is greater than 2, or x is greater than negative 1 or x is smaller than 2. The first set of ranges, x is smaller than negative 1 and x is greater than 2, is empty because there is no number less than negative 1, that is greater than 2. For the second set of ranges, x is greater than negative 1 or negative 1 is smaller than x, and x is smaller than 2 means negative 1 is smaller than x, which is smaller than 2, by the first fundamental concept in inequality. So, we are asking for whether negative 1 is smaller than x, which is smaller than 2. If a question asks for the inclusive relationship using ranges, solve by drawing on a number line. Don't forget that Q is K. Question is the king. Follow the second and the third steps. From the original condition, we have one variable, x. To match the number of variables with the number of equations, we need one equation. Since conditions 1 and 2 will provide one equation each, D would most likely be the answer. Recall 3 principles and choose D as the most likely answer. Let us take a look at each condition. Condition 1 tells us that x cubed is greater than 0. This inequality can be rewritten as x is greater than 0 by dividing both sides of the inequality by x squared. Since squares are always positive, so multiplying or dividing by non-zero squares does not affect the direction of the inequality sign by the first property of inequality, positive rule in inequality, and the fact you ignore the squares and even exponents. The range -1 is smaller than x, which is smaller than 2, that we are trying to find does not include the range x is greater than 0, contained in the range given in condition 1. If 0 is smaller than x, which is smaller than 2, then we get yes as an answer for asking whether -1 is smaller than x, which is smaller than 2. But if 2 is smaller than x, then we get no as an answer to whether -1 is smaller than x, which is smaller than 2. So, we have a no and a yes as answers to the modified question. Is -1 smaller than x, which is smaller than 2? Thus, the condition is not sufficient by CMT1, which states that the answer will be a unique yes or no. Condition 2 tells us that x minus 2 is smaller than 0. This inequality can be rearranged as x is smaller than 2. The range -1 is smaller than x, which is smaller than 2, does not include the range x is smaller than -1, which is contained in the range given in the condition 2. If -1 is smaller than x, which is smaller than 2, then we get yes as an answer to whether -1 is smaller than x, which is smaller than 2. But if x is smaller than -1, then we get no as an answer to whether -1 is smaller than x, which is smaller than 2. So, we have a no and a yes as answers to the modified question. Is -1 smaller than x and x smaller than 2? Thus, the condition is not sufficient by CMT1, which states that the answer will be a unique yes or no. If both conditions are put together, we have x is greater than 0, or 0 is smaller than x, and x is smaller than 2, which gives 0 is smaller than x, which is smaller than 2, by the first fundamental concept in inequality. Thus, the range -1 is smaller than x, which is smaller than 2, includes the range 0 is smaller than x, which is smaller than 2, that resulted from combining condition 1 and condition 2 together. Therefore, both conditions together are sufficient, and C is the correct answer. Let us look at the graph on the number line as shown below. Question: -1 is smaller than x, which is smaller than 2. Condition 1. X is greater than 0. This is not sufficient. Condition 2. X is smaller than 2. This is not sufficient. Both conditions 1 and 2 together. 0 is smaller than x, which is smaller than 2. This is sufficient. Both conditions 1 and 2 together are sufficient. Thus, C is the correct answer. Answer C.